All right, before we go over them, though, let me tell you that due Friday is all of the worksheets. That's pretty easy. Worksheet 1 through 5. The packet is due Friday when we test. Again, worksheet 5/review is really long, but it's been the only assignment for Tuesday and Wednesday and Thursday. So I don't feel bad about the length of worksheet 5. All right, number 30. Cosine. Y equals 4 cosine 1/2 x minus 1. So I want to do the ABCD, figure out the properties, and then use them in reverse, DCBA. But I think what would be helpful is to do a parent function cosine so I know basically what my graph should look like. So period for cosine is 2 pi. Starts at a max, ends at a max. So that's what my graph should look like, although it's going to be stretched and moved. All right, A is 4, so amplitude is 4. It's not flipped. B is 1/2, but that means the period is regular period over B. So keep it, change it, flip it if you need to. Hopefully we've done enough of these that you know that 2 pi divided by 1/2 is 4 pi. C is none. And D means down 1.
You should have put A, B, C, D, E in parentheses after. It makes it a little confusing. You should say like transform function.
Yeah, I don't. Yes, this is asked a different way than I would usually like to ask it. That's fair.
Wait, how do you spell period again?
The period is always normal period divided by B.
Okay.
So sine and cosine, it's 2 pi over B. Tangent and cotangent, it's pi over B. All right, down 1. But I need to be careful because my amplitude is 4. Right? So if I go down, if I put 1 down here, going 4 away from that's going to be a problem. So I need 1 to be not very far. So there's my midline. That's not an asymptote. You don't have to graph the midline, but I think it helps keep things straight. No phase shift, so that's my new origin is just down 1. Period is 4 pi, so I need to go 4 pi away. Peeking ahead, it says sketch at least 2 periods. So I think if I go right 4 pi and left 4 pi, that will get me 2 periods. So those are my other new origins. Amplitude is 4. Okay, so normally we start at a max. Cosine starts at a max. Where will my max be for this problem? 3, because I'm going to go 4 up from -1. 1, 2, 3, 4. And that'll be my starting point. And my ending point, because every beginning is the ending, and every ending is a beginning. It's where it starts over. All right, what's going on halfway in between the two maxes? What's going on halfway in between the two maxes? Not a 0. Halfway in between the two maxes is a min. So I need to go down 4. That puts me at -5. And then what's going on halfway in between a min and a max? Yeah, it's a 0, but 0 sort of in quotes. It's not really a 0 for this problem. It's a midline. I guess you could phrase it that way.
So what if we don't draw a graph as like perfect?
Well, it doesn't have to be perfect, but it better not look like that, right? There better be some curve to it. And then we repeat that going backwards, so it begins and ends at a max. Halfway in between we're at a min. Half of that we're on the midline. And there's our two periods of that graph. The maximum value is 3 and the minimum value is -5. The maximum is always going to be the midline plus the amplitude. The minimum would always be the midline minus the amplitude. Now, if you got the graph, it's easy to see, but sometimes we ask that question without the graph.
If it had a C, what difference would that make?
So a C is the left-right shift.
Okay.
We'll do that on number 31. Cynthia?
Oh, I was going to ask for another question.
Okay. Yeah, let's do 31 and then we'll take a different question. Because 31 has some different things about it and it's a sine graph. So it allows us to think, there's our sine parent function. Again, let's do A, B, C, D and then work backwards. So A is -2, but what does that mean? It's flipped and its amplitude is 2. Okay, so be careful. Capital A is -2, that makes it flip, but amplitude is just 2. B is 2, but the period is normal period divided by B. Normal period for sine is 2 pi, divided by 2 is pi. Period is pi. C, this is what you were asking about. So C is that minus pi in there. What does that do to the graph? Right pi. And then up 2. So this is a good one because this has like everything that could go wrong, not wrong, everything that could be changed or tweaked about a graph is being changed here. All right, so up 2. Although be careful before you go up 2 because you need to know like how far more above that and how far below that you need to go. But amplitude is 2. So I can actually know already my maximum value. How high is this thing going to go? 4. And how low will it go? 0. So it may be worthwhile to answer those first, because then you have an idea of what your scale should look like. So midline at 2. Again, it's not an asymptote. You don't have to graph the midline, but I think it's helpful. It helps sort of center the graph. I know my graph needs to be centered on that line. Then I'll go right pi to find my new origin, although I need to be careful because I need to think about what the period is. The period's pi as well. So I can come over a decent amount as long as 2 pi will also fit on the graph, because those two things kind of go together. So my new origin is pi, and my start over point is 2 pi, because period is 1 pi. So I need to fit now this graph in between pi and 2 pi, although it's been flipped. So I need to be careful. All right, so where do I normally start on a sine graph? Min, middle, or max? What was that? On the middle. And that means I start over on the middle. What about at the halfway mark? Two endpoints or middle points. What's the halfway mark at? Another middle. That would be 3 pi over 2 if we wanted to label it. How about halfway in between the first two middle points? Well, yeah, normally it's a maximum, but we're flipping, so I'm going to make it a minimum. And a minimum means down 2 from 2. So that would put it on the x-axis.
Why would it be the amount of
Well, pi over 2 would be over here.
Well, like on the parent.
On the parent function, it is at pi over 2. But our period has changed, so I don't know that I would care that it's at pi over 2. I would say it's at fourth of the way there. It's at the half of the half. Because, yeah, when we start switching phase shift and period shifts, then making those numbers match up isn't always easy. It's better to think, where does it begin, where does it end, what's it doing halfway, and what's it doing at the half of the half, the quarter points.
Do you have to write the 3 pi over 2 and 5 over 2?
You don't. As long as everything is nice and neat, you'd be okay without that. In fact, I'm definitely not going to write this one, although I could figure it out. Halfway between pi and 3 pi over 2. I'm really thinking about the unit circle. That'd be 5 pi over 4. Now, at the 3/4 mark, maybe is one way to say that. Halfway in between the second two zeros is a minimum, but we're flipped, so that's a maximum. So there's my function that's been all sorts of altered. It does say sketch at least 2 periods, so I'm going to back that up from pi back to 0, because that's 1 pi as well, from 0 to pi. It's 1 period. And it begins and ends at the midline. Halfway, we're at the midline. And then halfway in between there, we're at a minimum. And the other half, we're at a maximum. So there's my second cycle of the graph. Questions specific to 31? Anything on that graph? Those properties? Question? You were going to ask one?
Oh yeah.
Number 11. Which is an equation of the given graph? These are annoying because you have to graph 4 graphs to make it work, right? To see which one works. Although, you know what? We could start at the graph and maybe work backwards a little bit here. The midline is right there at -1. So I think I can rule out 2 of the choices. Right? My D should be -1 to drop the whole graph 1. So B and D are out. So that's, I guess, good news. Now we're at a 50-50 guess. Let's see. Amplitude is 2 for both. All right, now we're just going to have to look and see more carefully here. So cosine graph starts at a max, but that plus pi over 2 means means left pi over 2. So if we go left pi over 2 and start at a max, that that checks out. So I think A is good. If we go left pi over 2 and start at a max because we're cosine, I think A is going to work. Let's check C though, just to be sure. So a sine graph flipped. Switch to red here. Flipped and right pi. So if I go right pi, that puts me there. So the right pi checks out. So why doesn't C work? Because it's flipped. So if it was flipped, it would look right. It would look like this. So C's out because of the flip. So the starting point was right, but the flip was wrong.
What about the other points?
Like there's a point between like the negative pi over 2 and 0.
Like right there?
Yeah.
Like that just happens to hit the axis there. That's not a key point that we're concerned with. All our key points are always maximums, minimums, and midlines. We're not worried about anything other than that. All right, what else? Should probably do something with tangent. We could do 32 or let's do 20. Graph a tangent. Again, I think it's worthwhile to sketch a parent function when you're graphing these. It just sort of forces your brain into thinking, that's what a tangent looks like, that's where I'm headed. Let's see, ooh, A is -1, so we got to flip on this. I don't know that we flipped a tangent before, but we can do that. B is 1. What does that mean the period for this graph is? Pi. Because it's normal period divided by B, so pi divided by 1 is just pi. C is right pi over 2, and then plus 1 is up 1. Alright, so this is another one where we've jacked with 3 of the 4 things. The period is normal, but all the other things are messed up. So up 1. There's my midline. Again, that's not officially part of the graph. You don't have to draw it, but I sure think it's helpful. Right pi over 2 would be right there. Now I need to go pi away from pi over 2. This is a place where people get stuck because they think, oh, I'll go to pi, and that's where it starts over. I need to go pi away from pi over 2, which would be at 3 pi over 2. Right, 1 period equals pi. Did I mess something up? Are we good?
No, I was looking at the wrong part.
Okay. So I need to fit my graph in between, or at least those are my 2 new origins. Let's go back pi as well. Alright, what is tangent usually doing at the origin? It's on the 0. So my new origin has a 0 there. What's going on in between the zeros of tangent? Asymptotes. So for tangent, there's not really 5 points we have to graph, it's just get the zeros and asymptotes, correct? And then I almost sketched this wrong because I almost forgot about the flip. So normally we're increasing, but we've flipped over and gone decreasing. That looks like a cotangent graph. So as always, there's more than one way to write. If I just gave you that picture, the easiest way to write that picture, in fact everything's right, to just make that cotangent of x. No changes necessary.
Can we also graph over the negative neutrality? Like another zero?
Oh yeah, sure. If we were going to continue it, yeah, there'd be another one right here. Any questions on 20? Now we've seen a sine, a cosine, and a tangent. There was some debate in second period whether this is an easy unit or a hard unit. To me, I don't know, it could go either way, but I realize the debate happens because it's only one topic. It's if you understand what A, B, C, and D do, once you get it, it's like, oh, that's easy. I just do the A, B, C, D thing every time. But if you don't get it, then it's hard because that's all it is, you know, what does A do? What does B do? What does C do? What does D do? So it's that plus the parent functions. It's sort of one topic. We just did a whole bunch of different things with it. So if you get the one topic, it's an easy unit. If you don't get the one topic, it's a hard unit.
Wait, we're not stretching and shrinking tangents, right?
We won't ever stretch or shrink tangent. Do you remember why?
Because it has asymptote?
No, you could still stretch it with, I mean, you could do it.
Because we're not encapsulating.
Let me show you why. Yeah, the short answer is it basically looks the same. There's not much difference. So let's graph tangent of x. I don't know if this is a good window or not. That's a pretty good window. So there's the graph of tangent of x. Now let's graph 2 tangent of x. So we'll stretch it by 2. And I'll make it look a little different. I'll make it the bold one. So here comes 2 tangent of x. So the difference between tangent of x and 2 tangent of x, especially if you're graphing on your own paper, I hardly would be able to tell. So that's why we won't stretch tangent or cotangent, because you can't really. I mean, there's a difference, but when you're graphing on your own paper, there wouldn't be a whole lot of difference. If this one had it's even hard to do it. If I stretch it by 2, there's my new graph. It doesn't do much. Number 8. Ooh, that's a good one. Number 8. So this is kind of backwards. The period is 1 over pi. What's b? Well, period is always normal period over b. So period is 1 over pi. Normal period for a cosine graph is 2 pi. And we're trying to figure out what b is. So let's, I guess, cross multiply. b equals 2 pi squared, which is a weird b, but there it is as an answer choice. So that's one where we would never ask you to graph that, because how in the world do you graph a period that's 1 over pi? You're not going to graph that one. So a different way to say that is the ones that you have to graph, things work out reasonably well to graph okay. If it's not a graph, then we can get some weird answers because we're not doing anything with them. So we've graphed a little bit of everything. Oh, do we need to do a little bit of a unit circle review? I mean, why not? It's on the test. So let me teach the unit circle in 2 minutes. Here's what I remember, what I need to remember about the unit circle to get everything right. What's the shallow angle? Over 6. Over 6 is always shallow. What's the middle angle? Over 4. Over 4 is always the middle angle. Over 3 is always the steep angle. And then then I'm thinking about long sides, medium sides, and short sides. How long are all of the long sides? How long are all the long sides? Root 3 over 2. The medium sides? 2 over 2. And the short sides? 1/2. Some people remember it as root 1 over 2 to make the pattern fit, but square root of 1 is just 1. So if I can remember that, I'm probably going to be pretty good. Well, I guess I need to know that sine. How do I know what sine is? Which coordinate do I look at? Y. Cosine is x. What about tangent? Y over x. And then quadrants. So yeah, it's a lot of stuff. Let's answer a few from the back using that. Let's look at 58. Tangent of negative 7 pi over 6. So where is negative 7 pi over 6 is the first question.
The third one. Wait, no, it would be second quadrant.
The second quadrant, because it's going backwards. So shallow angle because of the 6. So tangent is y over x. The y coordinate is 1/2, just because I can tell it's the short side. The x side is the long side, and it's negative. So 1/2 over negative root 3 over 2. And then there's some cleanup work to do. Negative 1 over root 3, which is negative root 3 over 3. That was about as hard as they get, because it was backwards, it was a tangent, so we had to divide, and then we had to fix the radical. Let's do one of the ones that's on a quadrant, like 75. Plus it's a secant. So what quadrant is pi over 2 in?
1. No, middle.
Yeah,
Middle
trick
between 1 and 2.
trick question. It's not in a quadrant. It's between 1 and 2. So that ordered pair then would be 0, 1. Secant. How do I find the secant? Flip the cosine. And the cosine is the x-coordinate. So when I flip 0, that I can't flip 0. That doesn't work. Undefined, D and E. My suggestion for when you get the test tomorrow is, I don't know if you need to write down like unit circle stuff. Sorry, Friday.
Oh, Mr. Wolf.
Panic attack there. Some people will write this on the next few tests that we have, except maybe not the sign. They probably know that already, so they may not need to write that down. But I'll see like that much stuff written down, kind of get their brain thinking unit circle. So if that helps, do it. I think tomorrow it would be really helpful if you, like as soon as you get the test, do the parent functions. Sign function. Did I say tomorrow again? Sorry. Friday test. Sine, cosine. I'm just so ready to give you this test.
So confident on this, right?
I am. Tangent. So I think I would take 30 seconds, 45 seconds to draw those out, because then that's going to help you with so much of the rest of the test. So yeah, it's a little price to pay up front, but probably worth it, so that when we start asking questions about period and amplitude and you're having to graph them, you've got your own, sort of built your own cheat sheet to start the test with.
Wait, what's it?
Not mandatory, but I think helpful.
Just
Yeah, I think just the parent functions.
we can just write them on tests.
Yeah, just put them somewhere, at the top.
Sounds good.
You guys do that, like in this class and others.
Is it
There's
all-
some formula you got to know. As soon as you get it, you write it down. It's that kind of thing here.
Is it all multiple choice?
It is not all multiple choice because there is some graphing in there.
Well, that's stupid. Is it mostly multiple?
It's mostly multiple choice,
It's like four graphing or?
and then some graphing.
Would be like which equation fits.
But there's also some multiple choice graphing, like which equation fits the graph, or what's the graph of the equation.
Oh, so it's like the multiple choice with this stuff too.
Yeah, I mean it's just like the review. So the review has some that are, here's the graph, which equation works. There's a lot of here's the graph, which equation works. So second period didn't get a test outline, so I hope they'll watch the video. You know what? Let's make it a separate video. Maybe I can highlight